Welcome to question 5 of the Year 9 Acids End of Unit test. Yes, a scientist compared the acidity of 4 gases to see which gas might cause acid rain. She used 4 balloons to collect the gases. She then bubbled the gases in turn through a fresh sample of green, neutral, universal indicator solution. So here's my balloon containing the gas, here's my universal indicator solution, and she blew the gas that she collected in the balloon through the universal indicator solution. 3 of the gases caused the indicator to change colour. The scientist added drops of alkali to the indicator until the indicator changed back to green. Her results are shown in the table below. So here are the gases collected. She collected exhaust gases from a car, she collected carbon dioxide, she collected air, and she collected human breath. Use information in the table to answer part 1 and part 2 below. Which gas dissolved to form the most acidic solution? Right, so let's look at these. Well, we're looking for changing in colour of indicator. We know the universal indicator goes red in the presence of a strong acid or yellow in the presence of a weak acid. So how many acids have we got here? Green to red, that's an acid. Carbon dioxide, green to red, that's an acid. Air, no change, that's not an acid. Human breath, green to yellow, that is an acid, but we know that yellow is a weak acid on the pH scale, and we're looking for the most acidic solution, so it's not going to be human breath. So we've got to choose between exhaust gases from a car and carbon dioxide. Then we're going to look at this table. The number of drops of alkali needed to change the indicator back to green. So the more drops that I needed to change it back to neutral must be related to how strong the acid was. So if it was only a weak acid, I'd only need a small number of alkali drops to change it back again. And if it was a strong acid, I would need lots. So which needed the most drops of alkali to change it back? Look, it's the carbon dioxide. Needed 160 drops to change it back again. Now, for the full mark, you've got to identify carbon dioxide and you've got to identify why. And the key word is the most. It uses the most number of drops to change it back. Which gas formed a neutral solution? Well, let's look. Let's look up here. We've got 4 to choose from. Green to red, we know that's an acid. Green to red, we know that's an acid. Green to yellow, we know that's a weak acid. Hang on, no change. It must be air. Okay, it's air because when it was bubbled through the indicator, no change occurred. The indicator stayed neutral green. What effect does an alkali have on an acid? Well, this is just a piece of knowledge, isn't it? An acid plus an alkali is what kind of reaction? It's a neutralization reaction. So an alkali neutralizes an acid. Some metals react with acids in the air. Complete the word equation for the reaction between zinc and hydrochloric acid. Zinc plus hydrochloric acid makes something and something. Well, we know from our magnesium experiment back over here that when we add a metal to an acid, we get bubbles of hydrogen. Okay, so we know that hydrogen is one of the things we get for 1 mark. And we remember that hydrochloric acid makes chloride ions, and the zinc's had somewhere to go, so it's going to make zinc chloride, which is a salt. And we remember that from our metals unit, a metal plus an acid makes a salt plus hydrogen. The salt is zinc chloride and hydrogen's hydrogen. And that's the end of question 5.